Hey guys, this is Miss Bufford, and in this video, we're going to talk about naming ionic compounds. So our learning goals here are to be able to correctly name ionic compounds, including those with transition metals or polyatomic ions. We also need to be able to identify polyatomic ions in a formula and write the names of those polyatomic ions. And we also need to be able to distinguish ionic, covalent, and metallic compounds from one another. And that last one is just a general learning goal for this whole unit. So the first thing that we're going to talk about is how to identify an ionic compound. So when you're naming compounds, you're not going to be given, just a list that's identified as ionic compounds and then a list that's just identified as covalent compounds and being told to name them. They're going to be kind of commingled with one another on your exam and on your practice test in this unit. So you need to be able to look at a chemical formula and tell me fairly quickly whether it's going to be an ionic compound, a covalent compound, or whether it's a metallic compound. And when you're identifying ionic compounds, there are, some different things that you can look for. So, most ionic compounds, like we said, occur between a metal ion and a non-metal ion. And, one of these is going to have a really high electronegativity and the other one's going to have a lower electronegativity, and there's going to be that transfer of electrons that causes them to become ions and then, thus be attracted to one another after that. But ionic compounds can also occur between a metal and a polyatomic ion that has a negative charge. And so the metal here would be our positively charged cation, and the polyatomic ion is going to be the negatively charged anion. And remember that you can tell a compound contains a polyatomic ion if there are more than two elements in the compound. And so that's a really big thing, and we'll talk about this again here in a little bit. But if you look at a chemical formula and there are more than two elements in there, then you automatically know that that formula contains a polyatomic ion, and at that point it's just a matter of identifying, which elements are that making that polyatomic ion. And then more generally, an ionic compound can just occur between a cation or an anion. And, most of the time what we've talked about so far is that cations are always metal ions. But if you take a look at our list of polyatomic ions, there is one ion on there, ammonium, that has a positive charge. And so that particular polyatomic ion could take the place of any metal, in an ionic substance. And so it's not always going to be metals and nonmetals. You can have ionic bonds occurring between polyatomic ions. All right. So those are the three things that we want to be aware of when we're trying to identify the type of compounds that we need to name. And so the first thing we're going to talk about is the rules for naming ionic compounds that are made up of main group elements. So this is just the simplest kind, all right? So the first thing is given the formula. So we're given this formula, NaCl. We need to write the name of the compound. And so step one is to write the full name of the metal, and in this case, that's sodium. Our metal here is sodium. Then we're going to write the non-metallic root. So our non-metallic root is going to come from this non-metal right here. So we know that's chlorine. So if we take a look down here at this table right here that lists all of our common non-metallic roots, we want to find the one for chlorine. So the non-metallic root for chlorine is chlor. And then we want to end it with IDE, so chloride. And so when we put all that together, we end up with sodium chloride. And that is the name for this compound right here. Okay? So that's how we name ionic compounds that are composed of main group elements. So now let's talk about naming compounds or ionic compounds that contain polyatomic ions. And this is really simple. So, we're given this formula right here, NaMNO. And right off the bat, if I don't know that that contains a polyatomic ion, I can look and see that there are three different elements in this compound. And that means there's going to be a polyatomic ion in there. And so it's just a matter of me identifying which elements make up that polyatomic ion. And usually if we start with a metal here, then everything else in that compound is going to be our polyatomic ion. So let's see if we can find a polyatomic ion that has MnO4. And I'm looking over here. There it is right here. That is permanganate. All right. So let's go ahead and name this thing now. So we're going to write the full name of the metal. So that's sodium. That's what we've done here. And then we're just going to write the name of the polyatomic ion, permanganate. So the name of this compound right here is sodium permanganate. And that's pretty easy to do. You just have to identify your polyatomic ion, and then you can name it. All right, so now we're going to name ionic compounds that contain transition metals. And this one, the first two are kind of easy. This one can be a little bit tricky because you have to identify the charge on the metal to include that in the name. So let's go ahead and look at this. So we have Fe2O3, and we need to name this compound. So the first thing we're going to do is write the name of the metal. And then we need to determine the charge on that transition metal in the formula. And transition metals can have several different charges depending on the compounds that they're in. And you can determine this by using one of the two methods that we learned when we were writing these formulas. So I could use the charge balancing method, where I have to, so if I know that this compound contains 3 oxygens, I know that's going to be a total of -6 right there. And so that means that my iron, the total charges coming from all my irons, has to be +6. And so I just distribute that charge between those two ions, and that means that each one is going to have a +3 charge. All right. Or I could do the reverse of the crisscross method, and I could just crisscross these numbers right back up there. And either way, I get a +3 charge on that iron. And the way that I need to put this in the name is to use Roman numerals. So use Roman numerals following the metal's name to indicate the charge on each metal ion. So I've got iron 3. And then I'm going to use the non-metallic root for the oxygen here. So that's ox, and then I end it with IDE. And so the full name is iron 3 oxide right here. Right? So, a little bit more involved with the transition metal, but not too bad. It's using just the reverse of the methods that we learned for writing these formulas. And so let's go ahead and give this a try. So what I'd like for you to do is go ahead and pause the video and see if you can write the names for each of these compounds. And we'll come back and talk about them in just a minute. All right, so hopefully you've had an opportunity to pause the video and give writing these names a try. So this first compound is calcium oxide. So we've got our metal, then the non-metallic root for oxygen, and then we end with IDE. The second compound is going to be copper 2 chloride. It's really important to remember that copper is a transition metal, so we've got to include those Roman numerals so that we can tell the charge on that copper atom in that compound. All right, and then the next one is rubidium chloride, and then potassium dichromate. So we can recognize here that this has 3 elements in it, so there's a polyatomic ion. That first element right here, it's a metal, and so the rest of that compound is going to have to be the polyatomic ion. And if you're using your polyatomic ion list, you can identify that as the dichromate polyatomic ion. So I hope this video was helpful. If you've got any questions, go ahead and write them down in your notes, and we can talk about them in class when I see you guys next. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.